Today we'll discuss the topic current, voltage, and resistance. Quickly, we'll go through what is current or electric current. Current is basically the flow of the charges, like how many charges are moving in 1 second. The SI unit of the current is ampere, and we can represent the direction of conventional current, that is always from positive terminal to the negative, and the electron flow is always opposite, that is from the negative to the positive terminal. So when the question they ask, draw an arrow to show the direction of the conventional current. So you should always draw from positive to negative. Whereas electron flow, it's in opposite direction from negative to positive. So as you can see here, this is animated image. So current is basically the flow of the charges. And if it is moving from positive to negative, so the top one is actually the conventional current. Whereas the bottom one, it's from negative to positive, so that is representing the electron flow. So if we have electrons, they will move from negative terminal to the positive, but about the conventional current, it is from positive to negative. So number of the charges passing through the unit area in 1 second, that is known as electric current. And to calculate the current, it is charge divided by time. So total charge which is flowing divided by time interval will give us the current. And if we want to measure the current, we can measure by an instrument which is known as ammeter. So ammeter is basically used to measure the electric current. The circuit symbol for ammeter is a circle with the letter A. And when we connect these ammeters, we connect them in series. So in this question, in 10 seconds, 60 coulomb of the charge is flowing. What is the current? So current is charge divided by time. So charge is 60 and the time is 10. So the current will be 6 ampere. The second question, the current is 150 milliampere. So we have to convert into ampere. And the time is 3 minutes. So we should convert into second. To get the total charge is current multiplied by time. So that is 0.15 times 180, which will give us 27 coulombs. Then there are two types of currents, electrical current. One is called AC, another one is DC. What is DC? DC, the direct current, it flow in one direction, one way. But what is AC or alternating current? In which the particle flow in one way and then they return back. So it's like a vibration of the particle and they transfer energy. But in DC, actually the charges travel from one place to another. So for DAC, the terminals continuously changes. First, one side is positive, the other is negative. The next moment, it will be opposite. But for DC, it does not change. It continue to flow in one way. Then current in series, if we have a series circuit, the current will be same across each component. And if we have the parallel circuit, the current will divide between the component. Then connection of ammeter, how we connect an ammeter if we want to measure the current, because the current is same in series. So ammeters are always connected in series. So if you want to measure the current, we always connect an ammeter and that ammeter should always be in series. Then what is the concept of electromotive force or EMF? So electromotive force or EMF is basically how much energy is supplied to the charge from the battery, that is known as electromotive force, or we can also say EMF. Whereas potential difference, what is the concept of a potential difference? Potential difference means how much energy charges transfer. So as we can see here, if we have a 6 volts, we have a 6 volt battery. So it means it is providing energy, like 6 units of energy it is providing, or 6 joules of energy each charge. And there are two lamps which are connected in series. So half of the energy is transferred to lamp 1 and remaining half is transferred to lamp 2. So how much energy is transferred by the how much energy is transferred by the charges when it is passing through the component, we call that as a potential difference. And if we want to measure the potential difference, we use a voltmeter, and it is denoted by a symbol V with a circle. And potential difference in circuits in series, it will divide between the component. Like example, if it's a 6-volt supply, 3 volts and 3 volts are there between the two component. Where in parallel what happened, the energy which is supplied, it is same as energy supplied by each charge is same as energy from the battery. So if it's a 6-volt supply, each component will receive the same 6 volts. And if you want to connect a voltmeter, so voltmeters are always connected in parallel. So voltmeters are always in parallel, where ammeters are always in series. Then what is the concept of the resistance? Resistance means property of the material to stop the flow of the charges. Like example, as you can see in the beginning, the charges were flowing through. So charges are passing through the wire. But when we try to stop the charges to flow, when we try to stop them, or when we try to slow down the charges so they cannot move easily, what we call this characteristic, or what we call this property, we call that as resistance. So resistance is a property of a wire, property of a material to stop the flow of the charges. So when the charges are not able to flow easily, we call that is having a characteristic, and that characteristic is known as resistance. If we want to find the resistance, that is the potential difference divided by current. So resistance is actually voltage divided by current. How much voltage is there across the component and how much current is passing, we can find the resistance. So practically, if we want to measure the voltage, like if I say I have this component and I want to measure the resistance of this component practically. So to get the resistance, what we need a voltage. So to get the voltage, we need a voltmeter. So we'll connect a voltmeter in parallel. And to measure the current, we need an ammeter, and how ammeter should be connected in series to that. So we'll get the voltage, we'll get the current, and voltage divided by current, we will get the resistance of this material. This is how the resistance look like practical, like this is how the resistance look like, but we don't use, like we don't draw this, we just use a circuit symbol. So whenever we are using a circuit symbol for resistor, we use a rectangular box with the two lines that shows the resistance of a material. So resistance basically a property of a material to stop the flow of the charges. So the diagram shows a resistor connected in a circuit. So there's a resistor connected in a circuit. Calculate the resistance. So we have a voltmeter. The voltmeter shows 15. So if voltage across the voltmeter is 15, what is the voltage across the resistor? That is also 15. They will receive the same voltage because they are in parallel. And what about the current? Because this ammeter is in series with the resistor, so if 2 ampere is moving or flowing through the ammeter, same 2 ampere will flow through the resistor. So we have the current, we have the voltage. To get the resistance, that is voltage divided by current, so 15 divided by 2, that will be 7.5 ohms. That is the value for resistance of this material. So this is a simple concept of Ohm's law, which shows the relation between voltage, current, and resistance. So what is the resistance? Resistance is a property of a material to stop the flow of the charges, does not allow the charges to move. So resistance is actually a material property of a material to resist the flow of the charges. What is voltage? Voltage is the energy which drive the charge, energy which push the charges so that they can move. And what about the current? Current is the flow of the charges. So when charges start to move, they start to flow. What we call that as current. So resistance try to stop the charges to flow. Voltage is trying to push the charges, like energy supplied to the charges. And how many charges are moving every second? That is known as electric current. So if you want to measure the resistance, how we can measure the resistance? So to measure the resistance, we need voltage. For that, we can use a voltmeter. And how it is connected? It is connected in parallel. To get the current, we use ammeter. And how it is connected? It is connected in series. So we have a fixed resistor. If I say draw a circuit to measure the resistance of this resistor, so what you need a voltage. And how to get the voltage? So you connect a voltmeter parallel to this. Then we need a current, so we will connect an ammeter in series to this. And then we have a battery. So resistance will be equal to voltage divided by current. So when voltage divided by current, we will get the resistance of this material. So it can be any component here. It can be resistor, it can be lamp, any component is there. This is always the way, always the circuit to find the resistance. That voltage of the circuit divided by the current in through the component will give us resistance of that component. Then there are certain factors which can change. There are certain factors which can affect the resistance, the property of a wire to stop the flow of the charges. Number one, length of the wire. If we have longer wires, if a wire is having greater length, it will have more resistance. So we can have a longer wire, we can have a shorter wire. Longer wire will have high resistance compared to shorter wire which is having a low resistance. What is the reason for that? Because in a longer wire, when the charges have to move through a long distance, so they will collide with more particles, so that's why they find it difficult to move. But in a shorter wire, because few particles are there to stop them, that's why they're able to flow easily. So if we want to increase the resistance, we increase the length of the wire. If we want to decrease the resistance, we reduces the length of the wire. And the second factor on which it depends is the area, the cross-sectional area. So as you can see, if we have two wires, one is thick, another one is thin. So thick wires will have low resistance, whereas thin wires will have high resistance. Because resistance is a property of a material to stop the flow of the charges. As you can see in this image, as you can see here, when we narrow the passage, when we reduce the size of the here, when it is we have a thicker wire, the charges can flow easily. But when we reduce the size, the charges find it difficult to move or the charges slow down. That is why if we use a thinner wire, that will have high resistance as compared to thicker wires. So the length of the wire, the cross-sectional area, the temperature also increases. The effect of the, like increasing a temperature increases the resistance of the wire. for metals. So we have two types of materials, like mainly three are there, but in terms of conduction, there are two. One is the conductors, such as metals, and the other one is semiconductor, such as like LDR, thermistors, diode. So a material can be a conductor, or material can be an insulator, or semiconductor in terms of conduction. So what is the relation between the temperature and resistance? So for conductor, temperature and resistance are directly proportional. But for semiconductors, temperature and resistance are inversely proportional. So for conductors, when they become hot, their resistance increases. But for semiconductor, when they become hot, their resistance decreases. So it depends on the type of the material. Not all the material resistance increases with temperature. Some of the material resistance decreases with temperature. So the main three factors on which the resistance depend. Number one, the length of the wire. So when we have a longer wire, have more resistance than shorter wire. Number two, it depends on area. Thinner wires have high resistance than thicker wires. And number three depends on the temperature. But for temperature, it is not same effect. It depends on the material. If the material is a conductor or material is semiconductor. If it is a conductor, resistance increases with temperature. If it is a semiconductor, the resistance decrease with temperature. So these are the factors which affects the resistance. So example, if I say I have two wires A and B, same size, same area, but different lengths. Which one you think is having a high resistance, A or B? Which one is having a high resistance, A or B? Two wires, one is a longer, another one is a shorter. Yeah, that's right. A will have the high resistance. And if we have two wires of different areas, same size but different areas, which is having high resistance, A or B? Two wires of same length but different cross-sectional areas. Which one is having a high resistance? So in that case, B is having the high resistance. And if we have a conductor, so resistance increases with temperature, and this happened for what? This happened for conductors. And resistance decreases with temperature, and this happened for semiconductor. So if we have a conductor like metal wire is there, copper wire, copper is a conductor. We have two copper wires, same size, same length. One is at 30 degrees, another one is at 60 degrees. Both are made up of copper. Copper is a conductor. Which one is having a high resistance, A or B? Which wire will have a high resistance, A or B? Yeah, that's right. B will have the high resistance because copper, which is a conductor, it particles are not able to move easily. That's why the resistance increases. So when we sketch a graph, the IV graphs for conductor or resistor, filament, and thermistor. So when we sketch IV graph for resistor, for filament, and for thermistor, I is the current, V is the voltage. Filament made up of metal tungsten, whereas thermistor is made up of semiconductor. We have on y-axis we have current and voltage here, current, voltage, current, voltage. Here we have a resistor, a fixed resistor, which resistance does not change. Then we have a filament of bulb. Its resistance increase with temperature. As we use, the component become hot and its resistance increases with temperature. And the last one we have thermistor. Its resistance decrease with temperature. So as the temperature increases, its resistance. So when we sketch a IV graph for a fixed resistor, so it will always be a straight line. Always there will be a straight line. Because its resistance is not changing, so it is a straight line. But when we sketch a IV graph for a fixed resistor, for a filament, sorry, because what happened when we use a filament bulb, it produces heat energy as well, and due to this heat energy, the temperature of the filament increase. If the temperature increases, the resistance will also increase, and the rate of flow of the charges or the current start to decrease. So it will be like this. Because what it shows, or initially the current was increasing much faster, but with the passage of the time, as the temperature increases, the resistance increase. So that's why the current is increasing, but the rate of increase of the current is decreasing. Whereas thermistor, initially it is straight line, but what happened, as the temperature increases, its resistance decreases. As the resistance decreases, more current start to flow, so it will go up. So these are the three graphs, and which are very important. That first one, there is no change in the resistance. The second one, resistance increases. And the third one, the resistance is decreasing. Is it clear, the three graphs for resistor, filament, and thermistor? So if there is no change in the resistance, we call that voltage and current are directly proportional, and we say it is obeying a Hooke's law. Sorry, Ohm's law. Now, Hooke's law is for force and extension. But if resistance and like voltage and current are not directly proportional, it is a curve. It means that it does not obey a Ohm's law. So for filament is always a curve, but and at that the rate of the current is decreasing. That's why rate of change in current is decreasing. That's why the slope decreases. Then resistance in the circuit, series and parallel resistance. Example, if two or more resistors are connected in series and we want to find the combined resistance, so what we do, we add them, like example, 2 ohm and 8 ohm are connected in series. So we want the total resistance. So how to get the total? So we just simply add them. So it will be 2 plus 8. If there was another resistance, that we'll also add. But in this example, only two resistance are there. So 2 plus 8, that will be equal to 10. But if two or more resistors are connected in parallel, then what we do, so if two or more resistors are connected in parallel, so how we can find the combined resistance? So combined resistance will be equal to product divided by sum. Or we can also use a formula that 1 over R is equals to 1 over R1 plus 1 over R2. And then we can find. So when we add, like example, or we can also use the product divided by sum. So 2 ohm and 5 ohm are connected in parallel. So if they are connected in parallel, how to get the combined resistance? It will be the product. So it will be 2 multiplied by 5 divided by 2 plus 5. So product is 10 and the sum is 7. So it will be 10 divided by 7, which is equals to 1.43. So in short, when two resistors are connected in series, when the resistors are connected in series, what will happen? Total resistance of the circuit will increase. And if two resistors are connected in parallel, then what will happen? The total resistance of the circuit will decrease. So if we want the circuit resistance to increase, we connect the resistors in series. If we want to reduce the circuit resistance, we connect the resistors in parallel. Now some examples of finding the total resistance. Example, we want to find the total resistance of this whole combination. First, you can see the 2 ohm and 8 ohm are connected in what? They're connected in series. So if they're connected in series, so what will be the combined resistance? So the combined resistance will be 10. And this 5 ohm and 5 ohm are also connected in series. So what will be the combined resistance? That will also be 10. But that 10 ohm resistor now, they are in parallel. So how to find or how to solve? It will be product divided by sum. So 10 multiplied by 10 divided by 10 plus 10. So it will be 100 divided by 20. So that is equals to 5 ohm. So the combined resistance of this combination is equals to 5. Is it clear, this example? Same way, if we might have a parallel combination like two resistors in parallel and then series, or we might have two series resistor and then a parallel combination. So how to get the total? So we have 5 ohm example, 5 ohm, and then 30 ohms. So as you can see, first two are in parallel and then this 30 in series. So first we should know the combined resistance of these two. So what will be the combined resistance? It will be 5 because they're in parallel. So it will be product divided by sum. 5 multiplied by 5, 25, and divided by 5 plus 5, 10. So 25 divided by 10, that is equals to 2.5. So the combined resistance of these two is 2.5. And this 2.5 is now actually, because this is a combine of these two, is in series with the 30. So what is the total resistance? So it will be 2.5 plus 30. So that is equals to 32.5 ohms. Is it clear? Why we add them? Because as you can see, when this 5 ohm and 5 ohm are in parallel, so we find the combine of these two. So when we work out the combined resistance of these two, so it means now it become what? Because the combine is 2.5, so that combined resistance is 2.5, and that combined resistance is in series with now 30. So 2 point, because now they are in series. So what we do, whenever they are in series, we add them. And when they are in parallel, the formula is a product divided by sum. Same way, if we have this combination, say 3 ohm, 6 ohms, 10 ohm, and 20 ohms, and we want to find the combined. So first, how these two 3 ohm and 6 ohm are connected? They are connected parallel to each other. How 10 ohm and 20 ohm are connected? They are connected parallel. But when we find the combine of these two, that will be in combine, means like the total as one. So when we work out the combined resistance of these two, it will be product divided by sum. So 3 into 6 divided by 3 plus 6. So 3 into 6 is 18, 3 plus 6 is 9. So that is equals to 2 ohm. And here 20 and 10. So product divided by sum. So 20 into 10 divided by 20 plus 10. So this will be 200, and 20 plus 10, that is 30. So 200 divided by 30, or 20 divided by 3, we can also say, that is equals to 6.66. So this, when we work out the combined, this is the total is 6.66. And when we work out the combined here, that is 2. So this now 2 ohm, because that's the combined, and this 6.6 ohm. Now the combined resistance, the total, when we work out, these combined resistance are now in what? They are actually in series. So when they are in series, how to get the total? We will simply add them. So it will be 2 plus 6.66, that is equals to 8.66 ohms. So in series, we add them. In parallel, the formula is the product divided by sum. Is it clear? This example. And always remember, when resistors are connected in parallel, the combined resistance decreases. When they're connected in series, the combined resistance increases. Example 3 ohms, 3 ohms, 10 ohm, and 10 ohms. So we want to find the total resistance. So how to work out the total resistance? These two are in series, like A and B are in series, and C and D are in parallel. So first we should solve this parallel combination, and then we will add in series. So as they're in parallel, what is the combined resistance of C and D? So C and D combined resistance, product divided by sum. So 10 multiplied by 10 divided by 10 plus 10. So 100 divided by 20, that's equal to 5. So the combined resistance is equals to 5 ohm. And this 5 ohm is now in series. So this will be 5, 3 and 3. So it will be 3 plus 3 plus 5. So 6 plus 5, that's equal to 11 ohms. Unit of the resistance is ohm. You can use this Greek alphabet omega, or you can also write OHM. Is it clear? The concept of the resistance in circuit. So this was about the concept of resistance. The next session we will do questions, as well as there is also another formula which can be used to measure the resistance. Any question or a doubt related to the class?